Okay, so we're going to start testing the valves for the Heathkit oscilloscope. I'm going to start with the EZ81. Pop it in the socket here. Sorry, I've got a bit of a cold. Sorry, it's a bit sniffly. If we look up on the roll chart, EZ81, 6.3 heater-volts, same as an EZ80. So we're got two tests to do. Okay, so try and set this up so you can see everything properly. So I've got 6.3 there, and it says A, C, B, D, D, C, 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 C. A, C, B, D, D, C, 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 C. Right. So let's check the filament. So the needle's moved into the middle. That means that the heater filament is not broken. There's actually a physical connection there. We've got the needle set in the middle, and we can then do our next test. Now, when I move this to the first position, it's going to apply power to the valve and start warming it up. And if this light comes on and stays on, we know there's a short. So, there's the valve. You can see it's lighting up. Come back here. There we go, that's better. You can see now. We'll give it 30 seconds or so to warm up. Light hasn't come on, so that's the first electrode test. Second okay, third okay, fourth okay. It's okay if it flashes and the switch is off, that's fine. Next test is the emissions test, and we're looking for the needle to move. Hopefully it moves into the green. If it stays in yellow or moves into, is that orange or peach? We know there's a problem. So the first half of this valve test is testing in green. Probably from the angle you can see, it's not the best, but it's testing just under 9.5. All good. Right. To do the second test, we need to move that to C, and this one to A. Fire it up. So we've tested one side of the valve, now we'll test the other. Let's go. Right. It's still, filament's still on, it's all good. Test, test, test. Second half emissions. It's a very strong valve, isn't it? Look, that's about 9.5 again. Perfect. There you go. EZ81 is good. Right, I'm going to pull that out. It's nice and warm. We'll do the ECF80 next. These are all 9-pin miniature valves, and they all use the same socket. ECF80 up here. 6.3, 2 tests to do. Right. A, C, A, D, D, A, B, C, C. Double check that. A, C, A, D, D, A, B, C, C. So again, the first test just checks that we've got filament continuity. Oh, let's go. Right, I can see the valve lighting up. There it is. Hoping no orange light stays on, which would indicate a short. Good, 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 and it's testing. You can see that's just showing just below 10. First half is good. Second half, A, C, 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 D, D, C, C, B, A. A, C, C, D, D, C, C, B, A. Some of you find watching me test valves really exciting. Other people have commented that it's really quite boring. Unfortunately, it's just the process. It's what you've got to do. Why have you dropped? There you go. Unfortunately, there's something wrong with this needle. Maybe there's a dodgy solder joint inside. So the valve is still lit up. There you go, second half, super strong. That valve is good. That's the ECF80. So what I've got left is one ECC83, and I've got four 12AU7s. Now, ECC83, 12.5 volts on the heater, same as ECC81. ECC82, same as ECC81. So it's the same test for all three types of valve. Now, set 12 volts on the heater. What I'm going to do, rather than testing one half of a valve, switching it to the second, then doing the next valve, first half, second half, and so on, I'm going to test all 5 of these valves, one half first, then change the settings, then do the other half. Okay? So it is A, B, D, D, C, 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 C. A, B, D, D, C, 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 C. There you go. So ECC83 or 12AX7. All good. Oh, that one flashed on a bit. When we applied power to that, the filament flashed a bit. It's absolutely fine. Doesn't mean anything wrong at all. It's just probably hasn't been on for a while. Okay, can you see the needle? You can. Second position, third position, fourth position, emissions test. That's coming out about 9. Excellent. So first half of that one is good. Right, the first 12AU7. Filament is okay. That one flashed on as well. I'll film the next one in case it does it. Just so you can see what it looks like. Okay, so the valve is warming up. As we don't know when the last time anything was applied to these valves. There you go, there it is, about 9, 9.5. Excellent. Right. Are we going to be 3 for 3? Right, so check the filament, that's fine. If I power it on, I wonder if it's going to flash on. 3, 2, 1. Woo! Now, it's actually caused by a really cold filament. super cold, and there is a way you can stop it. Stop it happening. It's not. I mean, eventually, where that bright spot was that's causing the flash, that's where the filament will break. But these valves are, 40 odd years old and they're still going, so yeah, not much to worry about. Look at that strong valve. All this tester really does is obviously test for shorts, and it's just measuring the emissions in terms of current flow, which is, I mean, for the work I do, it's all it needs to be. All it needs to be. Right. That one flashed on as well. Tell you what, whilst that one is warming up, let's ask Google where was GDR. It's a question we need answering. Nice strong valve. Look. This is good. We're making loads of progress. Well, the half of that valve is fine. It will be good for using in this scope anyway. Okay. Let's just set that up there. Maybe you can see it flash on. Something wrong with that, isn't there? Where was G? Where was GDR? Question mark. Right, valve. First test flashed on. There you go. German Democratic Republic. Deutsche Demokratische Republik, commonly called East Germany. So all of these valves, I think, if they were made in the same factory, are German. So they're not Russian. There you go, I was wrong. Right, test. Mission's good. So there you go, that valve is fine. Now let's go and do the other tests. A, C, 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 D, D, A, B, C. A, C, 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 D, D, A, B, C. There you go, you can see it all now. Now, if they're German valves, that ties in with them saying on them, or some of them do, a Schlumberger company. Schlumberg. Frankfurt. Ah! On the back of the instruction manual is section 4, Deutschland. There you go, Frankfurt. German valves. I wonder if that became RFT or is it a different plant altogether. Excellent. Right, so this valve, both halves, test great. Next one. You see that one flash on again? If I'm honest with you, I don't think I was expecting to find any failed valves. we still might do, but with stuff like this, they're not really under a lot of stress, not like they are in a guitar amplifier. Good. Basically, as long as the needle moves to the right, it's good enough for me. It's actually quite cold in my workshop today. Should put a jacket on. Right. Oh good, oh good, oh good. Oh good. Right, 2 to go. 2 to go. Now, here's the question. If I know that 12AX7 ECC83, not this one here, but the one that's going to be going to test afterwards, is good, do I replace it with a new one anyway and use that in one of my own personal guitar amplifiers? I don't know, what do you think? I mean, new production ECC83s are everywhere. So I'm quite happy to do that. I don't know, what do you think? Should I... here it is, ECC83, Heathkit made. Foreign, it's probably German. It doesn't say on it like that 12AU7 did. But... I guess what I could do is just pop it in and see how I think it sounds. It could be the world's greatest sounding valve ever made. I doubt it, but you know, always worth a try, isn't it? Look at that. Nice and strong. 9-ish. Right, so that is all of the valves from the scope tested. I don't know. Yeah, I think I'll probably keep that for myself. I'll put it in a guitar amp. EZ81 is fine. I've actually got an old Mullard EZ81 and an old Brymar one actually that I could put in. Or is it a Mazda? Don't know. Instead, but as that works fine, I'm not short on them. I'm not actively searching for them, so I'm quite happy to put those in. So, with the valves okay, the next step, I guess... Now, let's think about this. My options are just shotgun it, replace all the caps for the sake of it, measure all the resistors as I go, and replace them if they're out of tolerance. Just get everything replaced and do it that way. Or I can do it one at a time, one component at a time. So we'd have to put a new cable on first, measure, turn it on, measure its performance, and then replace one component at a time and see if we can measure the change based on that component replacement. If I'm honest with you, I'm not particularly keen on the latter option, the step-by-step, one-by-one, simply because if one of the components is leaky, like one of these caps, and I keep turning it on and off, you know, I could end up damaging the scope. I don't know why the plug was removed, so there could be an underlying problem anyway that I could make worse or cause further damage. So I think, as I want this scope to be used in my shop, put it into service, it'll be used every day, I'm more inclined to go with the former option and just replace all the caps and then measure the resistors as we go. By caps I mean the electrolytics and what you might call a paper cap. Any of the micas or ceramic discs, we will measure them and replace them if we need to. I think that's the best way to do it. Gonna have to give it a clean up as well. Clean all the pots and switches, and then hopefully we can apply some power to it. So in the next video we'll start the process of that. I think that we'll have to start with removing the CRT very carefully, and put it away, wrap it up, put it away safely while I work on the rest of it. Okay, well, thank you very much for watching. I'll see you in part 3.